Question: a 24-year-old postpartum woman comes to the office for follow-up of gestational diabetes. The patient was diagnosed with gestational diabetes mellitus during routine screening at 28 weeks gestation. So she was treated with dietary modification, exercise, and record insulin briefly. So we can see that she had to take insulin. So since delivery 12 weeks ago, she has continued to follow dietary recommendations and her blood glucose has been fairly well controlled without insulin. The patient has fasting blood glucose level of 100 to 120 mg per deciliter. Medical history is otherwise unremarkable. The family history is significant for diabetes mellitus. Okay, the family history has got diabetes mellitus because her mother and gestational diabetes in her sister. Okay, so we can see an history of diabetes mellitus in the family. So vital signs are within normal limits. BMI is 22 kilogram per meter square. The physical examination shows no abnormalities. Her gestational diabetes and fasting hyperglycemia, Her gestational diabetes and fasting hyperglycemia are suspected to be genetically predisposed. Okay, so it means that her gestational diabetes and fasting hyperglycemia are suspected to be genetically predisposed, as she has got hyperglycemia and also gestational diabetes, and she also has family history. So this is suspected that she has got them by genetically. So this patient's condition is most likely caused by reduced activity of which of the following enzymes? Okay, so this was like bunches of informations, ideas, but the summary is very short. She has got gestational diabetes mellitus with the family history. That's it. So the answer is glucokinase. Okay, so why? So pancreatic beta cell function. Let's see. So glucose comes the GLUT2, like glucose transporter 2, and glucokinase here as an enzyme, glucose 6 phosphate pyruvate TCA cycle. It is creating ADP. So closure, like potassium is going out, calcium depolarization, and calcium okay, ADP is increasing here for TCA cycle, and there is also insulin, so exocytosis. Okay, so let's see. The glucose-induced insulin release from pancreatic beta cells triggers the following steps. Okay, so glucose-induced insulin release. First of all, the glucose enters the beta cell through glucose transporter, okay, GLUT2. The glucose is metabolized by glucokinase. We have seen it. Then glucose 6 phosphate enters the glycolysis to produce ATP. We have seen that the ATP is produced. Increased ATP levels causes closure of ATP sensitive potassium. Okay, so ATP sensitive potassium channels closure, right? Increased ATP levels. We have seen here that ATP level has increased, so there is closure of potassium plus channels. Okay, so increased ATP levels causes closure of ATP sensitive potassium channels. Depolarization of beta cells triggers opening of the voltage dependent calcium channels. Influx of calcium causes insulin release. Okay, so depolarization, as the depolarization of beta cells is happening, so that triggers opening of calcium channels. So as the depolarization happenings, the calcium channel is opened, so the calcium is infused. Okay, the calcium is going in, so the calcium has increased, and that's why what has happened, voltage getting calcium, influx of calcium causes insulin release, and the calcium has increased, so insulin got released, like by the process of exocytosis. So that was whole about this chart earlier. Okay, this one. So glucokinase has a lower glucose affinity than other hexokinase, which allows it to limit the rate glucose entry into the glucocytic pathway based on blood glucose level. It therefore functions as a glucose sensor for beta cells in controlling the insulin release. So glucokinase usually works as a glucose sensor for the beta cells in controlling insulin release, because we can see that okay, so heterozygous mutations of the glucokinase gene that decrease the activity or affinity of the enzyme cause a decrease in beta cell glucose metabolism, leading to reduced ATP formation and insulin secretion at any given glucose level. So first of all, just before reading this one, I would like to jump into educational objective. Okay, so let's read it first. Insulin release by pancreatic beta cells is stimulated by increased glucose metabolism and ATP production. Okay, we have seen that in the graph. Glucokinase functions as a glucose sensor in the pancreatic beta cells by controlling the rate of glucose entry into the glycolytic pathway. Okay, we have seen that glucokinase functions or controls the rate of glucose entry in the glycolytic pathway. Yeah, here the GLUT2, the glucose is entering into the cell, so GLUT2 or glucokinase here is controlling the how much of glucose is going to get entry here, because glucokinase is converting glucose into glucose 6-phosphate, right? So that's why the whole thing is dependent on glucokinase. Okay. Mutations in the glucokinase gene lead to a state in which higher glucose levels are required to stimulate insulin secretion and are a cause of maturity onset diabetes of the young. Okay, so mutations in the glucokinase gene. So if there is any mutation seen in the glucokinase gene, that is going to lead to a state where higher glucose levels are required to stimulate the insulin secretion. Okay, so higher glucose levels are required to stimulate insulin secretion and are a cause of maturity onset diabetes of the young. So if there is a mutation in the glucokinase gene, so that is going to lead us in a state where the higher glucose levels are required to stimulate the insulin secretion. So here, heterozygous mutation of the glucokinase gene, we can see the mutation is thought to be heterozygous mutation, decrease the activity of the enzyme and decrease in the beta cell glucose metabolism, leading to reduced ATP formation and likely insulin secretion at any given glucose level. Okay, so that has reduced the ATP formation. So glucokinase mutations are one cause of maturity onset diabetes of the young body. Glucokinase mutations are one cause of maturity onset diabetes of the young. Okay, this is called MODY, an autosomal dominant disorder characterized by mild hyperglycemia, which we can see in that woman that often worsens with pregnancy induced insulin resistance. Okay, so as the pregnancy has happened, so this MODY just got the parity and that showed some symptoms. In contrast, those more common type 2 diabetes mellitus patients with MODY are typically younger. Okay, though, because type 2 diabetes mellitus people are just older. So in case of MODY, that they are typically younger and non-obese, and they are also not obese. The condition is non-progressive and without treatment, and even without treatment. Okay, so this was all about this disease, glucokinase mutation. Okay, so the glucokinase mutation I will write here glucokinase mutation. So glucokinase mutation, so this usually happens in MODY, like maturity onset diabetes of the young. This MODY cause insulin when there is a mutation, glucokinase mutation is like excessive glucokinase ATP is increasing. As the ATP is increasing, the insulin is just getting out of the cells. Okay, so we are losing insulin, and when we are losing insulin, so that's going to lead us to diabetes mellitus. So that's it.